So following on from some of the previous videos, we were trying to sketch this graph here, and we got to this stage here where as x tends to infinity, this thing here goes towards infinity, and as x tends to 1 from the right hand side, it also goes towards infinity, and then as x tends towards 1 from the left hand side, then it would tend towards negative infinity. Okay, and then as x tends towards 0 from the right hand side, this here tends towards 0 as well. So this here is tending towards 0. This here is tending towards negative infinity. So this is a stage, the stage that we got to here. So here so we got to this stage where, well, the turning point could be above the x-axis, or it could be below the x-axis. We just don't know. The way we would know is by looking at the derivative of this. Our job now is to try and find the turning point of this. Find out when. So now we're going to differentiate this. Look at the derivative, and then find out where the derivative will be 0. You see, where the derivative is 0, that will tell you the turning point. Okay, so the turning point is when the derivative is 0. So we've got to find out the derivative of this. So let's now try and find out the derivative of this. So here, differentiate this. Rewrite this as this. Rewrite it as this, or you can just use the quotient rule and just differentiate it. So do whatever you want. Differentiate it. So that would take you to this stage here. Okay. So differentiate it. It would take you to here. And now find out when this whole thing here equals 0. So let this equal 0. Okay. So now let f prime of x equal 0. So set this to be 0. So now we are trying to find out a value of x where this whole thing here will be 0. Okay. So the turning point will be when the derivative is 0. So try and find a value of x where this whole thing here is 0. Okay. So now when you are here, visualize it as one bubble here divided by a bubble here. So now times both sides by the bottom bubble here. So that will then give you this. Okay. So when you're here, times both sides by this thing here. Okay. And then that will give you this. Now add 1 to both sides. That will then give you this. And then exponentiate both sides. So e this side and then e this side. That will then give you this. Okay. And then well, these two will cancel each other out. So remember, because natural log and e, they're the inverse of each other, so they cancel each other out. So for example, if you have e to the power of natural log of x, that will equal x. And then if you have natural log of e to the power of x, that equals x, because they will kill off each other. Okay. So this here will then give you this. So the value of x when you see when you set e to be, when you put this into the original thing, that, sorry, hang on, when you get, what this is saying is that when you the value of x when you will make the derivative to be 0 is when you put e into the x. So looking at this here, what it's saying is that now we now know that the turning point will be when x will be e. Okay, because when is e here, the derivative will be 0. So the turning point will be e. But don't forget, we are still at a stage where we know the turning point is at e. It could be below, or it could be above the x-axis. But all that we know so far is that the turning point will be at e. By the way, it's not to scale, because from here to here is 1. This here will be 2, and this here will be 3. E should be around here. But don't worry about scale too much when you're sketching graphs. But let me just reiterate. So here we just know that the gradient will be 0 when x is e. So the turning point could be here, or it could be well, it would be here. But our graph will either look like this, or it will look like this. We just don't know if it's above or below the x-axis. And the way we do that is by, well, we know the gradient will be 0 when we put e into there. So now looking back at our original function, so let's put e back into the original function. So when you put e back into the original function, when you put e into here, it will give you this, and then this thing here will be 1, because you can always imagine it. So these two cancel each other out, giving you this. Well, when you put e back into the original function, it will be e. So what that tells us is that it could not be this scenario here, because this will be the coordinates here will be e, comma, a negative number. But when we put e back into the original function, it gave us a positive number. Don't forget it's 2 point whatever. So the point here is that when we put e back into the original function, it gave us this. So it can only mean that this here is above 0. It cannot be this, because if you have this here, the coordinates here will be e, comma, a negative number. But then when we put e back into the original function, it gave us the coordinates of e, comma, e. So it can only mean this. So our graph now looks like this. Okay, so this is our stage at the moment. But here's the thing: with the naked eye, you cannot see. There is something happening in somewhere in between between infinity and e here. There's something happening around here, but you can't see it with the naked eye. The only way you can detect it is by looking at the second derivative. So there is something happening in between here. You just can't see it. The only way you can detect it is by looking at the second derivative, and that's what we're going to do in the next video. Okay, so the second derivative will tell us that there's something happening in between here. Okay.